Avni.
And I'm Alejandro.
We are both doctoral candidates working on the Ecomates project. Today we are excited to share with you what Ecomates is all about and how it's addressing some of the most pressing environmental challenges we face today. Let us take a moment to explain why this project is so important. Human activities such as burning fossil fuels, deforestation, and various industrial processes have significantly increased the amount of carbon dioxide in our atmosphere. This increase in CO2 is a primary driver of climate change, leading to rising global temperatures, melting ice caps, rising sea levels, and extreme weather events that are more frequent and severe than ever before. But there's a hope. One solution to tackle this problem is converting CO2 into valuable chemicals. These chemicals can be used across industries, helping to reduce emissions and create sustainable products. This process, often referred to as power-to-chemical technology, offers a promising way to turn a harmful byproduct like CO2 into something useful. This approach helps addressing the issue of climate change and is also plays a crucial role in mitigating the global energy crisis. By using renewable energy to drive these chemical conversions, we can create a more sustainable and circular economy. So let's explore this technology further.
As we all know, we need to use more renewable energy, and the good news is that the amount of solar and wind generation has been increasing dramatically over the last 10 years. However, by 2050, the EIA predicts that we need to have at least 5 times this amount to reach net zero. Now, this might seem feasible, but there's a catch to this. Let's look at an average day in Spain. Here is the energy demand. What you can see is that the energy demand is the lowest around noon and then peaks when everybody goes home, uses their electricity by turning their TVs and electronic devices. Now let's look at the solar and wind generation at the same time, and we can see that the solar power kind of peaks around noon, which is not surprising, and the wind generation is constant. Now, let us be optimistic and build 5 times the amount of solar and wind generation. What happens? Well, we get this. 2 problems pop out. The first is around noon, where we have way too much electricity, and then in the evening, when everybody starts watching Netflix, charging their phones after a long day of swiping on TikTok and Instagram, we don't have enough electricity to go around. So, what we need to be able to do is figure out how to transfer that electricity from around noon when it's in excess to the evening when people need it. And it's not just for transferring energy from one time of the day to another. We could have a cloudier season, so we'd like to transfer energy not just for hours or weeks, but for months. One way to do this is to take the excess renewable energy and use that to convert CO2 into products of value through a process called electrolysis. We can then store these molecules, and later when we need additional energy, we can use those in a fuel cell to generate electricity. This process is cheaper in terms of storage than batteries, which don't scale well with the amount of energy we want to store. However, this reaction is expensive and, as we can see, not as efficient. Therefore, the goal is clear: find materials that drive this reaction as cheaply and efficiently as possible. These materials are known as catalysts, and a clear example where these are used is in hydrogen-powered cars, where the hydrogen is used as fuel and then produces electricity and water as output. How? Well, using a platinum catalyst that is in the cathode of the fuel cell. In the case of the CO2 reduction reaction, the problem is not as simple, as aside from an efficiency issue, we are also dealing with a selectivity problem, because CO2 can be reduced to a wide variety of products with more value, like alcohols and hydrocarbons and so on. That's why our goal is to use the captured CO2 from our atmosphere in synergy with our current renewable technology to achieve a greener present.
So now, let's take a closer look at how we are turning the vision of Ecomates into reality. Imagine a chain where each link represents one of the 10 dedicated doctoral candidates working together to bring our technology to practical application. It all started with the first 3 doctoral candidates, Roy, Lan, and Chrysanthi, who are focused on the core of our project, developing catalysts using 3 different techniques. Their mission is to create the most effective material for CO2 reduction, the key of our environmental challenge. But we don't stop here. We also need theoretical backup, and to that we have Wei, Magnus, and Ali. These are our computational experts using advanced simulation together with AI to predict which material will succeed, how we can optimize their properties, and most importantly, how they work at a fundamental level. Their insights guide our next steps, ensuring we are on the right track. Once this promising material are developed, we hand them over to Alicia. Her role is to actually verify that such properties are fulfilled using advanced techniques based on X-rays. When the catalyst is ready and characterized, it's my turn. As doctoral candidate 8, my task is to prepare the substrate on which the catalyst will be developed, and it is called the gas diffusion electrode. I am focusing on the development of a robust electrode that can function for a long time. However, another important component of a cell is a membrane, which separates the component of the cell. And that's where Carmelo comes in. He is working on the development of membrane that will maximize the efficiency of our cells. Finally, we reach the last crucial link in the chain, Camilo. He is leading the charge in scaling up our technology, ensuring that everything we have developed can move from lab to the real world, ready for commercial use. So, as you can see, each of the 10 doctoral candidates has a unique role to play, but it's the synergy between us that allows this technology to advance step by step towards commercialization. So together, we are not just doing research, we are building the future of CO2 electroreduction.
Ecomates is part of the prestigious Marie Curie Doctoral Network funded by the European Union's Horizon 2021 program. Our network connects leading universities, research institutes, and companies across Europe. And together, we are 10 doctoral candidates that are being trained to conduct cutting-edge research that bridges science and real-world applications. Thanks for watching. We hope this gave you insight into our work, what a Marie Curie Doctoral Network does, and we encourage you to follow us on our social media for more updates and exciting results soon.